So what we are doing when we are graphing sine and cosine is we are graphing points, kind of like you did in the activity the other day, where we are thinking about that x value as being our theta, which represents a angle measurement in the unit circle, and our angle measurements are in radians. Okay, and so it's going to be based off of that. Before we begin graphing this, we need to scale our graph. Remember that our x-axis also represents theta, so you could label it with x, you could label it with theta, depending on what variable is in our equation. I will accept either. And then our y values obviously are going to be on the y-axis. Okay, let's go to the back of the first page to write down some definitions to better understand how we go about labeling our x and y axis. Okay, so the amplitude, this represents the height of the graph from what we call the midline. I'll explain the midline a little bit more later. And then the period length. The period is also a length. You heard me call it the period length. The period length is basically how long it takes before the graph repeats. Now, you don't have to guess these things. You can figure out these things just from looking at the equation. I have two examples over here. You can see in these equations, you see there's sine, there's cosine. Here's our x, which is, again, your theta. And on these problems, most likely you can see down below in example 1, you're more likely going to see an x than see a theta. But remember, that's what x is. It's our theta, which can represent a degree measurement. And for us, it'll be in radians. The way that you get your amplitude is from the a value, which would be the coefficient in front of our function. So these values right here, with these equations here and this equation, this equation here and this equation here, those values of A, those are going to represent your amplitude. Okay, the amplitude is your height. Your height, since it is a measurement, you always state your amplitude as a positive value, so we can think of the amplitude as being the absolute value of that A value in our problem. So if there's like a -3 in front there, your amplitude would be a 3. What the amplitude does to the graph is it can stretch our graph to be taller or shorter. I know that the graphs you did in the activity only went between 1 and -1, and that's because they were more geared towards the parent function of the graph. But our graph can transform by becoming taller. And with that, that means that you're going to have what we call a vertical stretch or compression. Some people like to say shrink instead of compression. Either word is fine with me. So that's what the amplitude does. It makes it shorter or taller. So the amplitude is going to help us to scale our y-axis. Okay. The period is how long it takes before the graph repeats itself. So you can see down here below, if I highlight that in, that's not very thick, but highlight that in like this, that is what I boxed in there is considered to be one period length, because that part of the graph right there, like if I trace that picture of the graph is going to help it happen again and again. So you can see it happens here, and then look, it happens again, and then it's going to happen again and again and again. It's almost like this is a stamp, and you could like stamp it here, stamp it here, stamp it, and it'd be the same thing over and over again. That is the period length. How long does it take before it repeats? And on the activity you did yesterday, that was 2 pi, because you went one circumference around the unit circle. Okay, so again, you don't need to guess what that is. You can calculate that. A period length is going to come from this concept that the unit circle is 2 pi. And sometimes it is 2 pi. That is your period length. Every 2 pi it will repeat itself. But we, again, can have transformations on this graph, meaning that it can be horizontally stretched or compressed. So that period length can become bigger than 2 pi or potentially be smaller than 2 pi. So what we do to get that value is we take 2 pi and we divide it by the value of b. Again, I'm going to say absolute value of b because, again, since this is a length, it should be positive. So anytime you're stating the amplitude or stating the period length, you should be giving positive values because they represent lengths, and we always measure lengths with positive values. So some people like to think of this as just 2 pi over b, and they know it's positive. But I'm just going to write absolute value of b as a reminder there. So the period length is going to allow you to scale the x-axis, that horizontal direction of the graph. So again, your horizontal or your period length is going to come from this b value you see here in the equation. That b value is going to tell you if you have a b value other than 1, that tells you that you're going to have some sort of horizontal stretch or compression. And again, if you have a horizontal stretch or compression, that means that your period length is going to be something other than 2 pi. Okay. If you don't see a value in front of this x, like if you look down at example 1, you see sine of x. There's a 1 in front of x. That means that the b value has not changed, which means my period length would just be 2 pi. If there's a value in front of the x, you're then going to have to take 2 pi and divide it by that value to get that length. Down here in this box here, something to know about these trig functions. If you're noticing, it starts to repeat itself. This is what we call a periodic function. A periodic function is basically a graph with a repeating pattern. And all of these trig function graphs have that repeating pattern, again, because it's all based off that unit circle, which means you're going around and around and around and around that circle potentially an infinite number of times. Looking at this, you can see here's the period length. I mentioned this word midline up above. Our midline is this line right here. That is our midline. So you want to label that. It's not labeled in this picture. The midline is something that you don't necessarily need to graph, but sometimes it can help you to graph it. Often, if we don't have a shift, which we'll talk about another day, your midline often is the x-axis. So for the parent function, your midline is going to be the x-axis. Okay? So I don't want to say it's always that because it isn't, but it is that for the parent function. And our amplitude is this height that is above the midline, and then that same height below the midline. So if I say my amplitude is 1, that means that from the midline I should go up 1 and down 1 with the graph. So this is just some general vocabulary about our trig function graphs for sine and cosine. So when doing these problems, the first thing that you want to identify is the period and the amplitude so that you can scale your graph. We will fill in this table in just a moment, but let's talk about the period length and the amplitude for our parent function. So for our parent function here, okay, remember that the amplitude is the a value. The a value comes first, just like a comes before b, right? It's this first value in front of the trig function. If there is no number there, that means that the a value is 1, which means that your amplitude is also 1. The period length comes from, for the parent function, it is going to be 2 pi. The reason why it's 2 pi is because the value in front of our angle measurement, x, or theta, again, we're going to be using x more often today, is a value of b. If you do 2 pi over 1, which is the value of b, you get 2 pi. So this is like your think bubble there. So this is going to allow us to scale our graph. So that's what we're going to do next, is we're going to scale this graph. Okay. When we are graphing these, I like to see 2 period lengths of the graph. So normally what I say to do is I want to see 1 period length to the left and 1 period length to the right. So that's what I'm going to label. Labeling the amplitude is pretty easy to do. You get to scale this graph however you want. So you could say that this is my 1. And so if that's your 1, 1, 2, 3, 4, 5, right? You could say that's 1. You'd have to make sure that negative 1, 1, 2, 3, 4, 5, make sure those are the same. Okay? Other things that you could do is you could scale this graph. You could say that this is 1. And so then this is negative 1. So it's really on you how you want to go about scaling that graph. Just make sure that the height, your amplitude, is the same above and below the graph. So since my amplitude is a 1, remember your x-axis for these parent functions, this is going to be your midline. That means I need to scale 1 above that midline and 1 below. So I'm going to do, let's see, 1, 2, 3. I'll do 4, and then that's going to be my 1. 1, 2, 3, 4. Make that equal, which means it's going to go down to negative 1. Your amplitude tells you how far above the midline and below the midline you're going to go. Remember, our midline is our x-axis. Some people like to put the midline on their graph. If you do that, 2 ways to show your midline: with a dashed line, so it doesn't look like an axis, or a highlighter also works, like I did here on the picture. Okay. Now, the next thing that we're going to do is we're going to scale our x-axis. Our x-axis, I want to see a full period length of 2 pi. So what we're going to do is we're going to label our x-axis, and we're going to make sure it goes the whole way out to 2 pi. So the way that I like to scale this is I kind of like do a tick mark every 2 to make this fit. And my last tick mark here should be my 2 pi. So we need to label these, okay? So if this is 2 pi, then this tick mark right here would have to be half of that. Half of 2 pi would be pi, right? Then this one would have to be half of, if this is pi, then this would be half of that. So that's pi over 2. If this is pi over 2, this is 2 pi over 2, right? 2 pi over 2, which is pi. So then this would be 3 pi over 2. Which then means that this would be 4 pi over 2, which doesn't that just reduce to 2 pi? So make sure that you scale your graph completely, and make sure that when you scale your graph, your radian measures there are in reduced fraction form. Now we could keep going to get another period length and go all the way to 4 pi, but I think it's easiest to think of this as your 0, and then just label these 4 in the opposite direction, but they make them negative. So then this would have to be negative pi over 2. This is negative pi, This is 3 pi over 2. And then this is, oh, sorry, negative 3 pi over 2. And this is negative 2 pi. You have to show that scaling. If your graphs are not scaled, you will not receive full credit for the problem. Okay? Because your graphs are going to be blank. They won't be scaled for you. Okay, so now we need to get some points. We're going to get our points from our unit circle. So what I would do is I would grab your unit circle from last class that we used for the activity so that you can look at that. Okay, so looking at your unit circle, we can see if you are at the, if you are at 0. And again, what does that mean? Y equals sine of 0, basically. Right? So if you're at 0 degrees, what's your y value on the unit circle? Well, that's going to, what is sine of 0? Well, that's going to be 0. Obviously, that one's pretty simple. If you're at 0, the sine value is 0. Now, I don't want you to look necessarily, you have to think about not the y value of the coordinate, but you have to think about those coordinates around the unit circle being a representation of cosine, I'll say x instead of theta, and sine of x, again instead of theta, where the x value of each coordinate on the unit circle represents the cosine of an angle, while the y value represents the sine value of an angle. So when we're doing the sine graph, we are thinking about those y coordinates going around the unit circle. And if you notice in my x chart here, all I have is the quadrantal angles. So now going to pi over 2, we can go to this picture down here. Whoops. I put a little diagram at the bottom there to sort of help you out if you don't want to get out your unit circle. So this was 0. Now we're here at pi over 2. So that means sine of pi over 2 is going to be this y value, which means it is a 1. So this is 1. And then you go to pi, the sine value at pi, right? This is pi over 2. This is 0 and 2 pi. This is 3 pi over 2. Let me just label that for you. The y value, when sine of pi, would be this y value, which would be a 0. Going down to 3 pi over 2, sine of 3 pi over 2 would be this y value here, which is negative 1. So again, what you're doing here is you're finding what does y equal when you're doing sine of pi over 2. What does y equal when you're doing sine of pi? And so on and so forth. And last but not least, what does y equal when you do sine of 2 pi? 2 pi is going to land you right back here the whole way around the circle. And that's going to be the y value of that coordinate, which is 0. And remember, if you've gone the whole way around the circle, which from 0 to 2 pi we should end up right back where we started. Okay, so now let's graph these points. So I'm going to go ahead and graph these. Here I have 0, 0, put a nice point there. Pi over 2, 1. Pi, comma 0. Then when we go to 3 pi over 2, we're down at negative 1. And then for 2 pi, we're back at 0. What you're going to see here is that when you're graphing these, the pattern that you essentially see is that you're going to go up the full amplitude height, down to the midline, and then what you should always go through the midline, down to the height, which is a height of 1, goes to negative 1, and then back to the midline. And then what's going to happen with this graph is if I were to do more points, it would keep going this direction. It's going to go back up to the height, back down to the midline, back down below, back to the midline. Remember, there should be no M's and no W's on your graph. Okay? Should be a nice periodic curve. Now, what's going to happen as you go the other direction, right? It's not going to shoot back up again. The pattern following this periodic function here's my full period length, right? That's my full period length. That's what's going to repeat over and over and over again, okay? So as we go left, we want that to repeat itself, right? I'm going to delete those so they're not in our way, okay? So what's going to happen as I go left? Is it going to go up? No, because then that would create that W. We don't want that. We want to keep repeating this pattern, which means I need to go down, and then I need to go back to the midline. And then I need to go up to the highest height, and then back to the midline. So what's going to happen after this? Well, it's going to keep going down, right? So this is going to go through our points like this, and then show that this keeps going. Show me that you understand that it's going to keep going this direction and not shoot back up. So I want to see these arrows on the end. So what we have here is we have 2 full period lengths, and then you want to make sure also that you show me where it's going to keep going. Okay? So that is the general idea of how you get the parent function for the sine graph. Okay, now what's going to happen when our amplitude and our period length change? Well, the period length, basically all that's going to change is it's going to change the scale of our x-axis. So again, remember that the period length helps us to scale the x-axis, and then the amplitude helps us to scale the y-axis. So as we go to problems with transformations, like on the back, you just have to think about how to scale your x and y axis. Okay? All right, so based off of that, I want you to go ahead and try to graph cosine. A few reminders here is that for cosine, cosine comes from the x value of the coordinates around the unit circle. So when you're going to fill in your unit circle, now I know this is very confusing, it says y. This y value represents what the value of cosine is when you put that angle measurement in. So this is saying, basically, this box right here is saying, what is cosine of 0? For cosine of 0, you have to go to your unit circle, which there's a nice little graphic down here, right? You go to unit circle, here's 0, and for cosine, we're grabbing this x value. So for this one, that answer is going to be 1. So this is saying, what is y when cosine, the angle of cosine is 0? So what does cosine 0 equal? It equals 1. Okay? And that comes from the x values of the coordinates around the unit circle. Okay? So you're going to go ahead and try this. You're going to scale it. You're going to fill in your table, name the period, name the amplitude, and then also graph those points just like we did up above. So go ahead and give that a try, and then we're going to stop there, and we'll go over some of the other examples together as a class. So good luck with this practice.